and check that I put every single mark in correctly, right? It's worth those few minutes just to make sure that I'm not like mistaken and, oh, turns out you earned more marks. Okay, so please do double check that. That's why I'm providing this to you. This is not your midterm mark. Your midterm mark will include this quiz and probably the next test. Okay, so quite a bit. Like if you want to boost your mark, there's still quite a few marks to be earned. Okay, we are not midway yet. Okay, there's still many marks to be earned. You can change your mark. Okay, yes, grab yours. That whole pile. Like, yeah. Also, reminder about Credit Rescue. Okay, about the quiz on word problems. Okay, that's coming up Tuesday. I will provide a little blurb with information and I will email it to you and post it just to make sure you see it. All right, so we're looking at page 13. Today's task is we're going backwards. Instead of graphing a function with transformations, we are taking a transformed function and figuring out its equation. So because we are going backwards, we're also doing RST backwards. Okay, so today is all about, where's my pen? Today, okay, why is my pen not working? Thank you. So today is about TRSSR. Right? So remember how like BEDMAS backwards is SAMDEB? Well, likewise, RST backwards is TSR. So when you're graphing, you use RST. When you're figuring out the equation, we use TSR, meaning we first figure out transformations, then stretch and reflection. All right. If you're moving your desk, please make sure you move it back. So let's see. I've got some steps labeled out for you. Step 1 is determine the parent function. Let's underline that. So the first thing you need to do, stop talking, is to figure out what is the parent function of the graph. Okay. Step 2 is to figure out the translations, right? So first we figure out the translations. Now, there are specific things for each parent function. If we're talking about a quadratic, if we have a parabola, then we use the vertex to find the horizontal translation and the vertical translation, right? The way we did in grade 10. If we have a radical function, we use the starting point to figure out how much it's moved left and right. And if it's a reciprocal function, we look at the location of the asymptotes. Okay, so that's what we do with the transformations. Then come the S and the R, and those kind of, we do both at the same time. So S and R. Okay, now really important. Yeah. Great. Okay. Do you remember how we talked about the fact that when you have a parabola and you do a horizontal compression, it looks like a vertical stretch, right? Like, look at me. I'm a parabola. I'm doing a horizontal compression. Well, it kind of looks like a vertical stretch. That's because it could also be written as a vertical stretch. So if you have a parabola that has both a horizontal compression and a vertical stretch, you could find a number to just make it one vertical stretch. So you can combine those. And this is helpful when we are finding the equation, because we are only going to find a vertical stretch. We are not finding the K value. Let me rephrase that. Write out the equation with only a vertical stretch factor of A, meaning no K value. Get off your phone. Do yourself a favor. And some of you might be like, what? Because if I'm doing this in a radical function and I have a negative a value, well, that just takes me here. But what if my radical function does this? That's a negative k value. So that is the one exception. So let's read on. Quadratics, radicals, and reciprocal functions can all be expressed using only a vertical stretch factor. For the purposes of this course, when finding the equation of a quadratic, radical, or reciprocal, they will only have a vertical stretch. Okay, but there may, however, be a reflection in the y-axis, in which case k equals -1. Do you know which is the only parent function that you need to think about this? Yeah. No. Yeah. Radical. Because if I have a reciprocal, and like if I have this part of the reciprocal and it's supposed to do this, well, this part can also do it, right? So the reciprocal, it still works out. Okay, so that's how we find the S and the R. And then to find the A value, oh, look, we're going to substitute a point back into the equation. Okay, and then we're going to check your work. Does it make sense? And the check your work is use your brain, use your critical thinking, which we are so good at, right? Because we do, this is where you might want to do some parabola or radical aerobics, right? To see, does it make sense? So let's try an example. Okay, determine the equation of this function. Step one. What's step one? Determine the parent function. What is the parent function? What is it called? Reciprocal, right? So we'll write f of x equals 1 over x. So I know I'm dealing with this, and I know my final equation needs to look something like this. Is anyone having trouble seeing? You can move your desk if that helps. Okay. Next, what's next? Oh, now we need to find the translations. And for the reciprocal function, it tells us to look at the locations of the asymptotes. Oh, yeah. Okay. So let's find out what are the asymptotes. What is the equation of this asymptote? Y equals 1. And this one is x equals 2. So what that means is, for the translations, the entire function went 1 up and 2 to the right. Okay, ask a question if this doesn't make sense. And as such, we can determine the C value, which is +1, and the D value, which is +2. Okay, we good for this? We've got half of it. Now we just need to find that A value. And again, with reciprocal functions, I don't have to think about the K as negative. Now, is there a reflection here? Yeah, we can tell there's a reflection. It will be taken care of when we find the A. So what I want to do now is just write the equation. So as I'm looking for, I'm going to write find A. You can drop it in any of the piles. I'll figure it out, and then grab your papers. So in order to do that, we need to write the equation. So it's going to look like this. You're that one. So 1 over, right? It's a 1 over. And the D goes next to the X. So it's going to be, is it going to be X minus 2 or X plus 2? Beautiful. X minus 2. And then at the end, we say plus 1. So again, stop me if you have questions. In order to find A, what must I do? Sub in 1 point. Yes. So this is me taking the parent function of the reciprocal function, adding the d, which goes next to the x, adding the c that goes after. And the a is in front, which I don't know yet. Okay, now let's find a point. Okay, I've got two nice points. This is a nice point. This is 0, 2. And then there's one here, which is 4, 0. Okay, I'll choose the 0, 2. You can choose whichever one. Could you use another point? Absolutely. You just have to make sure that you actually know. Like we have more, right? This one is a good coordinate. This one. So any point will give you the same a value. Yeah. So for the reciprocal, it will be taken care of in the a. So we're expecting that our a value will be negative because this also could actually be a negative a. It could be a vertical flip, right? Okay, so let's sub it in. Instead of y, I'm writing 2 equals a 1 over 0, right? My x is 0 on that point. 0 minus 2 plus 1. And now I just use algebra. So I'll bring I'll write 2 minus 1 equals a 1 over negative 2. How do I get rid of that negative 2 fraction? Multiply both sides by negative 2. Okay. So negative 2 times 1, a equals negative 2. So it did take care of it, right? We were worried. We're like, we know there's supposed to be a reflection. And because my a value ends up being negative 2, that means that reflection is accounted for. So now let's write the final equation. So we're not going to write an equation in function notation because I know what the parent function is. So let's see. We've got our a value. We've got the d value. And we've got the c value. Now you can write it this way, but I actually prefer if you multiply the coefficient into the numerator. So you're basically saying negative 2 times 1. And so the a value goes into the numerator. So watch this. Negative 2 over x minus 2 plus 1. Right? It's a little less cluttered. And I guess we could say a little more simplified. Once we get this equation, we need to pause and be like, is this good? Right? Did I get it? All right, let's go to the bottom one first. Let's do the reciprocal because we've never done this for the reciprocal. Okay. So first of all, I already told you the answer to the first one. What is the parent function? Oh, sorry, not reciprocal. That's why everyone's looking at each other. It's the radical, right? So we're working with a radical function. And then to find, so that's step 1. Step 2, to find the translations, we look at the starting point. This is the starting point, right? There's an arrow here. So how much, I can see there's a vertical reflection. I can see there's a horizontal reflection. Great. Let's not worry about that. Let's figure out the coordinates of the starting point. So I see it moved over 3 and it moved up 2, right? If this is the original starting point, then I had to move up 2 and across 3. So that means that D is 3 and C is 2. Now, in this case, we have 2 reflections. We have a vertical reflection and a horizontal. And this is the only one. Remember, there's this note that's bolded that says there may be a reflection in the y-axis, in which case K has to be negative. Let me show you what I mean. So what we're saying is if the monkey bar is the y-axis, right, we have to account for that in the radical function. So when we write the equation, we add an a value that is unknown, but then as we're writing the radicand, it looks like this: negative x minus 3, and then plus 2. So I don't give a value like a number to the k, but I give it its negative. And that negative accounts for horizontal reflection. So this is the only time you have to add a negative, is if you have a radical function that has a horizontal reflection. All right, we are given a point, so let's use that point. Sub in to negative 1. So if my y is negative 1, I don't know my a, my x is 2. I'm nervous because there's a minus under my radical sign. Okay, so let's solve. So we're going to get negative 1 minus 2. Thank goodness. I've got the negative of negative 1, which is what? Just 1. So what is a equal to? And now we take this a and we sub it in here. Yeah.
Where does this, like, 1 go?
This one?
No, the square root of 1.
Oh, well, square root of 1 is just 1. So I kind of skipped a step. And then we can write our final equation. Y equals negative 3 square root x minus 3 plus 2. We're keeping it in the factored form because that allows us to find our d value immediately. Okay, so don't expand the radicand, keep it factored. Did you have a question?
Would it be vertical reflection?
So it's actually both. So if you take the original function, the parent function is here. Okay, so it had a horizontal reflection, and then it had a vertical reflection, and then it moved over. So that's why I had to account for both by adding that negative. Okay, last one. Bear with me. We got this. I know we're going to go 1 minute into lunch. All right. Parent function, x squared. Okay? Because it's a parabola. I'm given the vertex. So that means I can say, okay, my d value, my horizontal translation, is negative 2. My c value is positive 4, right? Because it went 4 up. The vertex is where I find my translations. We're going to write the equation with an a value. So I don't know the a. I've got x plus 2 all squared plus 4. Right? This is a review of grade 10. We're going to sub in a point. I cannot sub in the vertex again because I've already subbed in those values. So I'll use a point that has a 0. Oh, that's not nice. I can't use it. This is my point. -1, +2. Okay, I'm going to sub in -1, +2. Okay, and we're subbing it in so that we can find the A value. Oh, take that back. 2 equals A, -1 plus 2, all squared, plus 4. Bring the 4 over. We got -2 equals A. -1 plus 2 is 1. 1 squared is 1. A equals -2. That's good. That accounts for our vertical reflection. And our final equation with the A is squared plus 4. Folks, there's one mistake in the homework question. So homework number 3 is actually supposed to be f of x, or we'll say y, equals -5 over 2 minus 4. Tomorrow, you're going to be doing more of this practice. Okay?